Hello. We're going to be doing one last problem on modified binary search. So with that being said, let's just get straight to it. Suppose an array of length n sorted in ascending order is rotated between 1 and n times. For example, the array nums, I'm not going to read that, might become either one of these depending on the number of rotates. Notice that rotating an array one time would just result in this. It's just rotated one time over. And given the sorted rotated array nums of unique elements, return the minimum element of this array. You must write an algorithm that runs in O of log n time. So that's why we want to do the modified binary search. Because it's O of log n. Yeah. So with that being said, let us get to it. If nums, this is our edge case here. If nums is less than or equal to nums sub -1, return nums 0. Oops. So basically, this handles a lot of cases. It handles the case where it's just a one number array. And it also handles just like technically an infinitely long array. It handles for the as long as it's already just in a regular sort, it'll just handle that case, right? So in typical binary search fashion, we need to do left, and the right is not right, length of nums -1. Typical binary search characteristic, where instead of doing less than or equal to right, we need to just do left is less than right, because if we're already at the number, like if we make them equal to each other and we look at the same number, we've probably already checked that number, so we don't need to do that, because since we're going to be checking both sides of the middle number. So we don't need to make it so that, like, left and right are equal to each other. We're going to calculate middle like we always do, left and the right minus left, and then floor division 2. I'll write the logic later, and we're going to return -1. This return -1 should theoretically never be executed. However, some compilers, like if you were to do this in an actual like IDE, it's possible that you don't get to compile your code successfully because you don't have an unconditional return statement, because all of our return statements will be conditional in this while loop. So we want to check two conditions. If the number that we're looking at right now, we want to check both sides to see if we have found the minimum value, right? So if mid is less than right and nums mid, is less than if it's greater than nums mid plus 1, then you want to return nums mid plus 1, because the only case where two numbers looking from left to right, the number on the left is larger than the one on the right, is when we reach the minimum value, which is on the right, which is why we're returning that, right? Because if we look here, 4, 5, the left one is smaller. 5, 6, left one is smaller. 6, 7, left one is smaller. This is our return case 0. We want to return 0, right? This is the only case where the left is larger than the right. 0, 1, 0 is less than that. 1, 2, 1 is still less than that. So this is the only case where we would want to return the number on the right, so we want to check that. If mid is also greater than left and nums mid minus 1 is greater than nums mid, same logic, right? Then return nums mid, because if the left side is larger than the right side in a regular sort, that wouldn't happen. So like, we just look at the same thing, right? If the left side is larger than the right side, then we return the right side, which is what we're doing here. right? And so now we haven't found the min value yet. So if nums left is less than nums mid, then we will do, so the left side is sorted and we want to find the unsorted area, right? So we want to do left is equal to mid plus 1, and then else right is equal to mid minus 1. Because that means the left side isn't sorted in this else statement, right? And so, we'll just keep going through, and then we'll figure out like the value that way. And so if we run it through, so for this one, 5, we check the left, we check the right, and the right is less than, so we return that. This is actually the same test case, so I don't know why they use that as an example again. This is handled in our edge case where the first value is just less than everything, so we just return the first value. So let's do something like 2, 4, 5, 6, 7, 0, 1. Think, right? Because it's the same value as this, but now it's rotated one more time. So our middle is 6. We check the right side and the left side. It's in sorted fashion. So now we check the left side. It is sorted. Therefore, we will make our right bound like this, 7, because we move left to mid plus 1. 7, 0. Now we get 0 as our mid number. And then so with 0 as the mid, we check the right. We're not greater than the right because 0 is less than 1. Now we check the left, and then 0 is less than 0 is in fact less than 7, so return 0. And yeah, so let's just submit our code, and boom, it works. So yeah, with that being said, thank you for watching.